Welcome to our session on electrical transformers. In this sixth video, today we will explore the thermal management of these essential components for the electrical system.
So, as if we were in a classroom, we will clarify some doubts about transformers, which work tirelessly to bring energy to our homes and cities.
Let's start with the basics. What are transformers and why are they so important?
A transformer is a device that regulates the electrical voltage. Imagine a hose with a lot of water pressure, but you need to water delicate plants. You would need something to reduce the pressure, right?
Of course, otherwise the plants would fly away.
Exactly. Transformers do something similar with electricity, adjusting the voltage for efficient transmission over long distances and safe use in homes and industries.
It is like a road system. Highways to transport energy and smaller streets to distribute it to each house.
That is an excellent comparative. There are different types of transformers, such as power, distribution, and isolation transformers, each with a crucial role.
But how do we know if a transformer is working properly?
Temperature is a key indicator. Like any machine, transformers generate heat, and an excess can be a sign of a problem.
Is it like putting a thermometer on the machine?
Exactly. In fact, in the analog age, transformers were only controlled by a simple thermometer in contact with the transformer oil. But nowadays there are special sensors that monitor the temperature in real time. If the temperature rises too high, cooling systems such as fans and radiators are automatically activated. Not only this, but they allow you to view event histories to analyze the root cause of the possible problem.
It is fascinating how these systems work to protect transformers and ensure a continuous power supply.
I am interested in these topics. What other tools do engineers use to diagnose transformer problems?
Two key techniques are dissolved gas analysis, DGA, and frequency response analysis, SFRO, DGA. This is like a blood test for the transformer. It detects gases in the insulating oil that indicate possible internal faults. SFRO. Similar to an ultrasound scan, it evaluates the mechanical integrity of the windings and core, detecting deformation or damage.
It is impressive how these techniques allow engineers to act as detectives, investigating transformer signals to avoid major failures.
Let's move on to maintenance. What are the main approaches?
There are three key strategies: preventive, like a regular medical checkup. It includes periodic inspections and tests to detect problems before they occur. Predictive uses sensors and algorithms to monitor in real time and anticipate failures. It is like an early warning system. Reliability-centered maintenance, RCM, prioritizes resources at critical points according to the potential impact of a failure, optimizing maintenance management.
These strategies ensure the efficiency and reliability of the electrical system and transformer, right?
Undoubtedly. Applying them correctly minimizes interruptions and optimizes costs.
Now let's talk about efficiency. What causes energy losses in a transformer?
Losses come from within the core, by magnetic hysteresis and eddy currents. Hysteresis is like the resistance of the core to change its magnetic state, while eddy currents are like electrical eddies that generate heat, in the windings, due to the resistance of the conductors, which generates heat when the current passes.
And how can we reduce these losses?
By means of advanced materials, special core steels, and high-purity copper conductors, optimized designs, improved core geometry and winding arrangement, efficient cooling systems.
This not only improves efficiency, but also reduces environmental impact, right?
Exactly. Energy efficiency is essential for a sustainable future.
We learned a little more about thermal management and transformer efficiency, a fascinating topic and fundamental to the stability of the power system.
I hope you found this information useful. If you have any questions, you can contact Antonio Fresco Navasarada on LinkedIn. Thanks for joining us. See you next video.